In this video, we will be looking at Module 2, Lesson number 3, Ratios, Rates, Proportions, and Percents. Now that may seem like a lot of topics to be in one lesson, but they are all very closely related. We start with a ratio, which is just a comparison of two different quantities or amounts. And the first step in looking at a ratio is to convert it to fraction notation. Now our ratio in number 1 is 72 to 76. Ratios are very often written with a colon like that, and we can convert them to to a fraction by just writing 72 over 76. Typically, we write the first number as the numerator and the second number as the denominator. Now 72 over 76 can be simplified, right? They often say it in the directions, but always have to look to simplify. And now I know both of those numbers are even, so they're definitely divisible by 2, but it actually turns out that 4 is a factor of both 72 and 76. 72 can be written as 4 times 18. 76 can be written as 4 times 19. And again, as I've said in the previous two videos, right, another way of thinking about that is that both 72 and 76 can be divided by 4. So we can cancel out that 4, leaving us with 18/19. So 72 to 76 is the same as 18 to 19, or 18 over 19. Okay, so that's a ratio. The next step, a rate, is now a ratio with two different units. So instead of just looking at two different numbers, those numbers now contain units, and they're typically different units. So we can simplify them just as we've done in the past. And the first step, though, is to take our rate and write it as a fraction. So if we drive 120 miles in 2 hours, we can write that rate as 120 miles over 2 hours, and then simplify that fraction. 120 is evenly divisible by 2, so that would be 60 miles over 1 hour. And I just use the word per. A unit rate is a rate in which the denominator is 1. So when the denominator is 1, we usually just take the shorthand there and say the word per. So 50 miles over 1 hour is the same as the common way to say that is 50 miles per hour. But it's understood, it's implied that the hour means 1 hour. Next, we're going to look at proportions, and a proportion is an equation of two equal ratios, a fraction equal to a fraction, or a ratio equal to another ratio. And proportions have what's called equal cross products. So using those cross products, we can determine if two ratios are proportional to each other. So in part A here, we're saying is 10/4 equal to or not equal to 15 over 6. And we can answer that question by taking the cross product, and what that means is to multiply 10 times 6 and 15 times 4, and determine if those two products are equal to each other. So we're really asking a question. That's a question mark. Are those two values equal to each other? 10 times 6 is 60, and 15 times 4 is also 60. So those two cross products are in fact equal. Okay, so that would then mean that 10/4 is equal to 15/6. In part B, we're asking a different question. Is 2/10 equal to or not equal to 5 over 25, or 5/25? Now we can do this by looking at their cross products, multiplying 2 times 25, and saying, is that value equal to 5 times 10? And since 2 times 25 is 50, and 5 times 10 is also 50, then those two fractions would in fact be equal to each other. 2/10 is equal to 5/25. Now we'll take that one step further and look at solving proportions, and we're still going to use cross products. So you see how each slide or each topic in this section is just building a little bit on the previous one. We use cross products and our equation techniques to solve for an unknown value in a proportion. The first problem there says solve for x. 3 over x equals 14 over 20. Using cross products, we're going to multiply 3 times 20 and say that that is equal to 14 times x. And we're going to solve for the value of x. 3 times 20 is 60. And then on the right-hand side of this equation, we still have 14 times x. And using our equation techniques, we can divide both sides of this equation by 14 to leave us with just x. And in this case, x would equal 60 over 14. Now they said do not round, okay, so we're not going to punch that into our calculator or anything and get that in decimal form. Okay, but what we can do is take that 60 over 14 and write it in simplest form. 60 over 14, both of those values are divisible by 2. 60 is 2 times 30. 14 is 2 times 7. Our 2's can divide nicely, and we're left with 30 sevenths, or 30 over 7. That is the value of x that solves our equation. Now in part B, we're still going to use cross products and our equation techniques to solve. In this one, we'll have a fraction to deal with in taking our cross products, but we start it the same way. We'll multiply 5 times x for half of the cross product, and 45 times 2 ninths for the other half of the cross product. Now I'm going to work just on the right-hand side for just a moment, simplifying 45 times 2 ninths. And we can do that by multiplying those two fractions together. We can write 45 as 45 over 1, and we're multiplying that by 2 ninths. 45 times 2 is 90. 1 times 9 is 9. And then 90 over 9 is equal to 10. 90 divided by 9 is 10. So our equation really says 5 times x equals 10. And our equation techniques allow us to divide both sides of this equation by 5, and 10 divided by 5 leaves us with a value of 2. And that should also make sense, because if 5 times x is 10, well, 5 times 2 is equal to 10. So there's our solution to part B. Next, we put all this together and answer some application problems. Number 5, on an architect's blueprint, 1 inch corresponds to 6 feet. Find the length of a wall represented by a line 5.5 inches long on the blueprint. So we can write that initial information that's given to us. 1 inch corresponds to 6 feet as a ratio 1 inch to 6 feet. The other piece of information, the length of a wall represented by a line 5.5 inches long, we can write that as another ratio, 5.5 inches to an unknown value of feet, an unknown number of feet. So we have two different ratios that we're working with here, and we can write them both as fractions. 1 inch to 6 feet would be 1/6. 5.5 inches to an unknown number of feet would be 5.5 over x. And once again, we'll take our cross products to solve this equation for x. 1 times x is equal to 5.5 times 6. Now to multiply those two numbers on the right-hand side of the equation, we need to write our first number, 5.5, as an improper fraction. 5.5 would be 11 halves. 5 times 2 plus 1. And that 11 halves we're going to multiply by 6 over 1. Now 11 times 6 is 66. 2 times 1 is 2. Finally, 66 divided by 2 is 33. And I'm not going to forget about the left-hand side of the equation, 1 times x. Well, that is the same as just an x. So we have x is equal to 33, and since that is my answer to the problem, I'm going to go back and remember what my units are supposed to be. In the original problem, it says that 1 inch corresponds to 6 feet. We're looking for the length of the wall corresponding to 5.5 inches. So that 5.5 inches would correspond to 33 feet. Now, the final step in this lesson is to look at percent notation, and an interesting fact about percents is that it dates back to ancient Rome, where Emperor Augustus taxed goods at a rate of 1/100th, and the modern day percent notation is written as n%. So they just use the same ideas, but without the actual percent notation. But now n means per 100. That n% means n per 100. This allows us to write percents as ratios. Any percent given to us is just a ratio out of 100. 50% is 50 out of 100, 50 over 100, or 1/2. Okay, and we can write these percent application problems and solve them using, of course, proportions, which we just looked at. So in number 6, we have 5% of 700 is what number? Now, 5% is 5 over 100. 5% of 700 is what number? So we're looking for the part out of the whole 700. So to solve that ratio, that proportion, excuse me, we use our same cross products. 100 times x is equal to 5 times 700. Simplifying the right-hand side, 100 times x is equal to 3,500. 5 times 700 is 3,500. Dividing by 100 gives us that x is equal to 35. Okay, so 5% of 700 is 35. In number 7, we're looking at the question is worded a little bit differently. Instead of looking for the part out of the whole, we're now going to be looking for the percent. And how do I know that? Well, when I read it, it says 19 is what percent of 57. So we're looking for the percent. So I can write this one as x percent over 100, right? We can always write our percent as a number out of 100. It's just that in this case, the number is unknown. So x over 100 equals, now 19 and 57, 19 is the part and 57 is the whole. They're saying 19 is what percent of 57. In this case, the 57 is acting as the whole value, and the 19 is the part. Okay, so there's our equation, our proportion, x over 100 equals 19 over 57. We take our cross products and write 57 times x equals 19 times 100. Simplifying the right-hand side gives us 57 times x equals 1,900. And then dividing by 57 gives x equal to, now this is not a whole number, but it is a fraction. If you divide 57 into 1,900, you actually get 33 and 1/3. 33.3 repeating is 33 and 1/3. And since this question asks what percent, 19 is what percent of 57, we are going to write 33 and 1/3%. So anytime that you're solving a problem that asks for a percent, make sure that you do in fact include the percent symbol in your answer. All right, finally, we're going to be looking at number 8 now. 30 is 150% of what number? Now I can start this out by writing my percent down. My percent is always a number out over 100. So 150 over 100 equals, Now 30 is what is 150% of what number? 30 in this problem is the part, and the number, the unknown value that we're looking for, is the whole. We take our cross products, as we've been doing, and multiply 150 times x is equal to 30 times 100. 150 times x on the left-hand side, I'm just rewriting that, and then on the right-hand side, 30 times 100 is 3,000. And again, as we've been doing in the last few problems, we divide both sides by that 150, and when you do that, we have 3,000 divided by 150 is equal to 20. So 30 is 150% of 20. Okay, this brings us to the end of Module 2, Lesson number 3. Thank you.